I'm Monte Zweben. I'm the co-founder and CEO of Splice Machine, and I've got about a 10-15 minute little talk about battle scars. And Splice Machine has reached a point of inflection very similar to, I think, what Lars was talking about before, and all the speakers were talking about, which is a point of inflection about being real. And while we had a number of customers implementing our database, I think this is the first time at an HBase Con we can say we've really scaled. And we learned a lot, and we have some serious battle scars, a lot more gray hair, and a lot of experience that I'll share with you today very quickly. Just as a reminder, for those of you who don't know who Splice Machine is, we're a relational database management system, not just a SQL layer, but a full transactional relational database management system built on HBase. We also have Spark inside of our system so that it can be a translytical, or what's called HTAP system, so that it can support both full commits and rollbacks of transactions with an MVCC transactional architecture, and at the same time be able to handle very complicated analytical workloads. And the way it works is that people issue SQL to a load balancer or to any particular node. We parse it, we plan it, we optimize it with a cost-based optimizer, and then we compile out the bytecode for the instructions that represent an optimized plan, and that bytecode then gets dispatched either to HBase or to Spark, depending on whether the optimizer interrogates it and decides that it's an analytical query or a transactional query. We have the HDFS as our main persistent storage attached to HBase, and agree with some of the things Lars was saying about the future of storage systems attached to HBase. And we deploy both on-premise for our customers, as well as being live on Amazon, as well as on Azure, and that'll be announced this week as well. So in terms of SQL, we support a full ANSI SQL, most of 2003 and some beyond. Some of the interesting things, like we were talking about a moment ago about indexes, we support full secondary indexes, commit, rollback, window functions, some of the things that you really need. Our goal at Splice Machine was not just to be providing SQL access to HBase. We had a very ambitious goal of being able to take people's traditional SQL workloads that might be running on Oracle, SQL Server, MySQL, or Postgres, and be able to transition them over to our platform. And so it is essentially trying to make it simple for people to do translytical workloads. But let's get to the meat of the matter here and talk about some of our battle scars. I'd like to talk about one particular customer who is in the financial services arena. I can't name them now, but they have a customer service application, essentially. And that customer service application is attached to a call center as well as to a programmatic API. And this particular system had a very robust, many-year transactional history, and that transactional history needed to be loaded into Splice Machine, as well as to create a real-time stream of enterprise transactions coming into the system. The system was architected with a Kafka stream and 2 versions of Splice Machine running for high availability, a live and a backup version. And so if you look at the numbers of this particular implementation, it really put us to the test. And we had to make a lot of changes, some of which I'll talk about here. We needed to be able to handle 2 years of enterprise transactions, but also be able to take in and delete 2 billion records a day. This amounts to about 7+ petabytes of data, about 500 billion records, and the schema involved was a complicated schema. This originated in a traditional relational database management system, but at much lower scale, and it had 700+ columns. There are 7 indexes per major table, and there are, from a user perspective, over 2 million queries hitting the system a day, both programmatic and from the call center. And we needed to maintain roughly an SLA of, for very complicated queries, roughly being able to 98+% be less than 2 seconds. And most of the time, we're in the milliseconds, less than a second, for this particular problem. This was a huge challenge for us. We hit a number of issues. Many companies have dealt with compaction, sometimes by just turning it off, but at this scale, you cannot do that. And you can't manage it by turning it off and turning it on in certain windows. What we needed to do is take compaction and take it off of HBase. And so we basically moved it off heap and moved it onto our Spark executors. So now Spark uses its spare scheduler to squeeze in the compaction jobs as appropriate. And this has proven to be very effective for us. And I'm just showing a little screen here of the Spark console showing compaction jobs being, you can't really read that because it's so small, but compaction jobs being interweaved with actual SQL going on. This was a major improvement. It made HBase much more stable for us. Then we hit the laws of physics. And one of the things that we realized is that based on the 2 years of records that we needed to ingest into Splice Machine, using just our normal write pipeline and inserting records, this would probably taken us a year to just literally just ingest that many records. And we had to engineer something different. So we took advantage of HBase's bulk import, but we did something important before it hits the HBase bulk import. We take delimited files, and using Spark, we use Spark to partition the data in a very careful way, and I'll talk about the partitioning in a minute. And then we sort the data, and then we create H files that are temporary H files, and then we use the HBase bulk import mechanism. We packaged this capability into stored procedures in Splice Machine so that the users can control this process and make sure that indexes and that base tables are imported in this bulk fashion with transactional integrity. This was critical. We would never have been able to load that many petabytes of data in about the 4-month period that we had to do so to make our critical deadlines. But this was a major improvement. And in fact, we use this bulk loading capability even while streaming real-time data in for the enterprise transaction store. So this was a major improvement for us. We implemented a very traditional representation of tables in HBase. We used a transaction ID that was encrypted as the first part, the prefix of the primary key, with a date and then a sequence ID for daytime transactions. And what we realized is that being able to keep a rolling window of time meant that with this representation, the primary key was pretty much spread all over every region. So that meant that deletes of a day, when you're trying to keep that two-year window, was going to hit every region, which means that the compaction processes would actually be writing every region. And this was untenable. We went back to the drawing board and said, let's see, can we come up with something better? And we actually just simply came up with a better key structure where we prefixed the key with a month. And that allowed us now to concentrate the processes that are going on and be able to merge and do the proper compactions without having to touch every single file in the system. This was critical for us. The downside of it was that the users now had to modify their queries. And this is, they modify them by having to put that prefix in front of their queries for performance. So this really speaks to the need for partitioned tables in Splice Machine, which is a future for us. But at least that workaround was sufficient for this particular use case. Now that we had this prefix with this new key, of course, that led to hotspotting, because now we were streaming in enterprise transactions during the day, and they were all in the same month. And so we were also getting rid of transactions from the 2-year window. And that was all in the last month, the 25th month. So what we needed to do here is somehow deal with this hotspotting issue. So like most HBase implementations, we had to be very smart about pre-splitting and create the proper regions. And as you can see here in this chart, what we did is simply take the base tables and the indexes and create more regions for the early partitions than in the middle, where things are kind of cold, where there aren't as many transactions, and then have a large number of regions in the final month that has a lot of writing going on because of the deletions. So this 2-year rolling window really was important both from a key representation and a region structure. But we were able to make it work and meet our goals. And then last, with regard to ingestion of real-time data, we had to use the bulk H-file ingestion that I talked about earlier, but we also innovated in another way, and this is somewhat related to the Spark interfaces that Lars was talking about. We had to build something really powerful for our Spark interface. We built a native Spark data source that essentially allows for normal CRUD operations on a data frame in Spark that manifests itself or materializes itself inside of HBase. So now within Spark, you can actually operate directly on data frames, insert data frames directly into a Splice Machine table, and you could see that down here in the bold down below there, where you can insert a data frame directly into a table, and it does so transactionally. We also have delete, update, and bulk import and create table operations. This was critical for us to be able to avoid JDBC serialization as a normal Spark data source would provide. This is actually quite performant, and it also is great for people who are doing analytics, because now in a notebook structure or just in their Scala or Python code, they can write their data frame manipulations, their transformations or actions, just like they would normally in Python or Scala, but be using their data frame programming patterns, but then it's actually materialized and made durable in a transactional store like HBase inside of Splice Machine. Just to conclude, those are some of the battle scars we wanted to share with you today. Just want to give a shout out to our team who worked so hard on some of these implementations. So that's all I have, and I really appreciate the opportunity to tell you a little bit about our battle scars.